this is 5.7a, which is going to be our introduction to inverse trig functions. So we've been looking at inverse functions all year, especially first semester. So basically what an inverse function is it's asking the question in a different way. So instead of saying sine of this equals what, you're saying sine that equals this is the sine of what. So you're saying...
Like Jeopardy?
Yes. Actually, yes.
Nice.
So you're saying, for what value is sine equal to this? For what value is tangent equal to this? Like that. So, for our inverse trig functions, because we can only find the inverse of functions that are 1-to-1 and pass that vertical line test, or not 1-to-1, that's what a function is. 1-to-1, meaning they have to pass the vertical and essentially horizontal line test. We have to do our inverses for a very specific chunk of space. So we are going to start with sine. So for y equals sine of x, we are only going to be looking at our inverse from negative pi over 2 to pi over 2. So I'm just going to draw a little graph, and it's not going to be perfect. Negative pi over 2 and pi over 2. And I know that sine of 0, and I'm going to label this as we'll put 1 there and negative 1 there. I know that sine of 0 is 0. And then I know that sine of pi over 2 is 1, and it curves up this way. And then I know that sine of negative pi over 2 is negative 1, and it curves this way. So this is the little chunk of our sine graph that we are going to find an inverse for. So this is from negative pi over 2 is less than x is less than pi over 2. Less than or equal to, sorry. So if you guys remember, inverses were essentially switching our x's and our y's. When we solved to find inverse functions first semester, we would replace f of x equals with y equals, switch x and y, and then solve for y again. So that's what we're going to be doing, is switching our x values with our y values. So the graph of y equals sine inverse of x, so that negative 1 is what we use for sine inverse. That graph is going to look like this. So I'm going to draw another little graph. And this time, I'm going to label my y-axis with pi over 2 and negative pi over 2. And I'm going to label my x-axis with negative 1 and 1. And so the domain of sine inverse is going to be from negative 1 is less than or equal to x is less than or equal to 1. And the reason why is because we're switching our x's and y's. So it was pi over 2, 1 is now 1 pi over 2. 0, 0 is still 0, 0. And what was negative pi over 2, negative 1 is now negative 1, negative pi over 2. Then, because we didn't graph all of the little points in between, this is important, it's going to curve this way. So curve it that way, and I shouldn't have gone past there. And we're going to actually, for our exact values, we'll make a table here in a second. Yes. Yeah. So, basically, what we're doing is we are saying, when does sine equal negative 1? And then we're specifying it to be specifically in this region, because we only can do like one repeat of it for it to have an inverse function. So this is just the section that we do a repeat for, or the section that we do our inverses for. We are now going to make a table of the exact values. And when I said, hey, today is one of those days where you're just going to literally use your notes to do your assignment, this was what I was talking about, the table we're about to make. So our exact values of sine we're going to put in a table, and we're going to go from negative pi over 2 to pi over 2. So we are going to say that this is theta, and then this is what sine of theta is. We're going to go from negative pi over 2 to pi over 2, and we're going to do that we're going to do it for the same values that we did it for 0, 30, 60, 90, and then essentially 0, negative 30, negative 45 to negative 60, negative 90. We're going to do it in radians, though. So negative pi over 2 would be equivalent to negative 90 degrees. Negative pi over 3 is equivalent to negative 60 degrees. Negative pi over 4 is equivalent to negative 45 degrees. And then negative pi over 6 is equivalent to negative 30 degrees. So negative 90, negative 60, negative 45, negative 30, and then 0. And then we're going to repeat those all for positive as well. Pi over 6, pi over 4, pi over 3. I have to make myself one more box. And pi over 2. Okay, we know these values from when we are evaluating things on the unit circle. It's those same values. So sine of 0 is still 0. And then sine of 30 degrees or sine of pi over 6 is 1/2. Sine of pi over 4 is square root of 2 over 2. Sine of pi over 3 is square root of 3 over 2. Sine of pi over 2 is 1. So these are the same values of sine for 0, 30, 45, 60, and 90 that we've been using all semester. Okay, then your negatives are going to be the same but negative. So sine of negative pi over 6 is negative 1/2. Sine of negative pi over 4 is negative rad 2 over 2. Sine of negative pi over 3 is negative rad 3 over 2. And then sine of negative pi over 2 is negative 1. So those are the exact values for this graph here, essentially. And here is how we are going to use those today. You are going to be asked to find the exact value. So this is like our first example, per se. So this is what your questions are going to look like. That pen doesn't show up. I did darker blue. That's better. Okay, so you are going to be asked to find the exact value for which, let's our first example, let's say when sine inverse of rad 2 over 2. So then literally all you do is you are saying when, and it'll specify between negative pi over 2 and pi over 2, is sine equal to square root of 2 over 2. So you literally just say that happens at negative pi over 4. That's pi over 4. Why do I have negative written down from last year? Did I miss something?
Is that all we're doing? Is that like actually all we're doing?
Well, I'm trying to figure out. Yeah, pi over 4. I don't know why I have a negative written down here. That's a typo from last year. All right, so that's literally all we're doing, and we're going to do that for cosine and tangent as well. Okay. I'm only going to do one example because that's literally all you do is you say, okay, when is it square root of 2 over 2? It's when pi over 4. So it says, for what value of sine is my answer square root of 2 over 2? That's essentially what it's asking you. All right, let's talk about cosine. And I am not confident in my ability to fit this on the same sheet of paper. So I'm going to move to another sheet of paper. I'm finicky like that. All right, so for cosine, we are going to be looking at, let me zoom back out here. For cosine, instead of going from negative pi over 2 to pi over 2, the repeat that we use, or the segment that we use, has to be from 0 to pi, because that's where we go all the way from 1 to negative 1. So for my graph, I'm going to go from 0 to pi. This is going to be 1. This is going to be negative 1. So the reason why is because cosine of 0 is positive 1. And then cosine of pi over 2 is 0. Cosine of pi is negative 1. And so this will curve this direction. So this is just this little chunk of a cosine curve. And the reason why we have to do that is because if we were to do this chunk, it would just be the top half. We need both the top half, like a quarter of the top and a quarter of the bottom, so that we have everything between positive 1 and negative 1. So our value, our domain for our inverse functions for cosine is going to be that 0 is less than or equal to x is less than or equal to pi. So then when we graph our inverse function, which I'm just showing you what the graph looks like, when we graph our inverse function, y equals cosine inverse of x, it's just going to be like a tall, skinny graph starting at 0 here. And it's going to go all the way up to pi. So the inverse of cosine, we had a point at 0, 1. So now we have a point at 1, 0. We had a point at pi over 2, 0. So now we have a point at 0, pi over 2. And then we had a point at pi, negative 1. So now we have a point at negative 1, pi. I'm switching my x's and y's. And then it'll curve the opposite direction. We're not doing the exact values in between. But it'll curve this direction. And the domain of that is from negative 1 is less than or equal to x is less than or equal to positive 1.
Are we almost done?
We're going to do this, and then we're going to do tangent as well.
Or like hearing and understanding what I'm just trying to copy.
Okay. There's a video posted.
No,
So if you want.
It's not what I'm saying. I'm saying like, I can't actually listen because like you move so zoomy fast.
Okay.
I'm still trying to write and draw all this stuff out. But
Okay, then stop. Then ask me to slow down and stop and ask questions, okay?
I don't need you to slow down. That's not the thing. I just need to hear it. I can't be trying to keep up writing.
So then what do you need?
Don't say that. Don't mind my fellow. That's cool. But no, like I need you to like why, you know? Like the more of like the majority of making this. Why can't we just hear it? No, I'm trying to put this into words. It's like it just appears on your paper, like you're not drawing it out. Like it appears on this paper, you're explaining it while you're doing it. We can't draw it and listen at the same time. But you can put it on the paper and say it. We're not understanding. So I need you to make it so we can understand it.
So what do you not understand?
Yeah. Repeats.
What?
I think repeats will make you an Excalibur teacher.
Okay, so you're saying just explain where we got this from?
Like, is everyone done? Let me go over it.
Okay, so assuming that everyone's written this down, when some of us,
like, how about you just draw it out? Don't explain it while you're drawing it out. Like, is everyone done drawing it? Then tell us.
well, it doesn't mean anything if I don't explain it. So I'm willing to re-explain it, but I'm not going to not explain things while I'm giving them to you. Okay, so this is a graph of cosine, just half of a period, because we can't do a whole period, because if we did a whole period, we wouldn't be able to find an inverse because it's not 1-to-1. So we can only do something that a vertical line can cross and a horizontal line can cross. So we choose to go from 0 to pi because that gets us all the way, all of our different values are seen once. This is the inverse of that function, meaning we switched our x's and our y's. So instead of having a point at 0, 1, we have a point at 1, 0. Instead of having a point at pi over 2, 0, we have a point at 0 pi over 2. And instead of having a point at 0 or pi negative 1, we have a point at negative 1 pi. We are now going to write down the exact values of every point along here that you guys are going to use today. So those exact values of theta
So, like, if we didn't excel on the last thing, we're not going to be able to understand this.
Those exact values of theta are 0, we're starting at 0, and then 30 degrees is equivalent to pi over 6. 45 degrees is equivalent to pi over 4. 60 degrees is equivalent to pi over 3.
Oh, no, I get it from going all the way back.
And then 90 degrees is equivalent to pi over 2. So that takes us from 0 to pi over 2. And then we need to do our values from pi over 2 up to 1 pi. These ones are a little weirder with fractions. This is going to be 4 pi over 3, because that's pi over 2 plus pi over 3, so it's like 1 pi over third further. Just kidding. That's JK. Rewind. So this, I'm going to break things down into 12s. So this should be 120 degrees. 120 degrees would be equivalent to 2 pi over 3, because it would be equivalent to 4 pi over 6. Then 135 degrees would be equivalent to 3 pi over 4.
So on that thing that we do a long time ago, they'll be like directly across one another?
Yes. Yeah. And then next equivalent to pi over 6 would be 5 pi over 6. And then 1 pi. Okay. We know that cosine of 0, here, let me be ready to do values. Okay. We know that cosine of 0 is 1 from right here. We know that cosine of pi over 2 is 0 from right here. And we know that cosine of pi is negative 1 from right here. And then it might be easiest for us to go up from 0 to positive 1 and down to negative 1. We go 1/2 rad 2 over 2, rad 3 over 2. These guys will be positive. These guys will be negative. So
positive of the positive in the negative, the inverse.
these guys, yeah. Okay, so pi over 3 is 1/2, and 2 pi over 3 is negative 1/2. Pi over 4 is rad 2 over 2. And 3 pi over 4 is negative rad 2 over 2. And then pi over 6 is rad 3 over 2, and 5 pi over 6 is negative rad 3 over 2. Okay, I want to show you guys here. You keep writing those down. I'm going to pull up a unit circle because I want to show you guys these points on a unit circle. So, yes. Pull up a big unit circle. I don't want to Google Lens this. I just want it to be large. Okay. Are we ready? Can I put something on top of this now? Okay. So this, I clicked on this from Google Images. Now I got to go find it. All right. So we've got the unit circle here. Our unit circle values are cosine, comma, sine. So if I zoom in here, the first number is going to be cosine. So this is labeled in degrees, not radians. But here is 1 square root of 3 over 2, square root of 2 over 2, 1/2, 0, negative 1/2, negative rad 2 over 2, negative 3 rad 2, negative 1. Those are the values you just wrote in your table. And these are written in degrees because it's just the one I found on Google Images, but it's the same as your radian measurements. So those are our cosine values. And then our sine values would be the second number in our ordered pairs. And we go from negative pi over 2, which is negative 90 degrees, to positive pi over 2. And that's because we go from negative 1 to 1. So that's how we can cover everything from negative 1 to 1. So we're just doing half of a period of each function. What's up?
I have a question.
Yes.
I've definitely probably already asked it before, but what does circle like? What does it do with triangles?
What does the circle have to do with triangles?
Yeah.
So every single one of these. So when the unit circle is derived, every single one of these is a triangle. Is a triangle. And so if you guys remember when we did like the X, Y, and R, that's what that is. And so this is a 60-degree angle. That right there would be a 30-degree angle. So that's a 30, 60, 90 triangle. This is a 45, 45, 90 triangle. And so those were those three special triangles. A 30, 60, 90, and a 45, 45, 90. And then this is just a different 30, 60, 90. And that's why we do them all from the x-axis. And so like that's why we do that one. And then we also do this one. And then we also do this one. Yeah. So that's what it has to do with triangles. And we should look, I don't think we're going to have time today. We should look back at that unit circle rolling trig function video at some point. Maybe we'll do that today. We'll see. Okay.
We should do that right.
What time is it? 10:05? Okay. 10:05. Let me see if I can find the one I like real quick. If I can. I think this one's good. I've watched it before, so. Well, the music's off. Okay. So that's the unit circle with 1, on each side. So now here's just quadrant 1. There's that first 30, 60, 90 triangle I drew. And they're labeling that anterior angle as theta. That's our y value, which is sine. That's our x value, which is cosine. Not sure why they drew a line there. That's just a tangent line. Okay, and so then that's that triangle that we were talking about.
So wait, tangent is that white line that like meets the points of cosine and sine?
Okay, I don't know what they're doing here.
Where's tangent?
Okay, this video be wildin'. This is not the video I was looking for. I think this one might be. Where did that go? It's embarrassing how many of these I've watched. Okay, there was a one over on the side there. That's the one I was looking for, I think. So it was on the suggested on this. I shouldn't have clicked off. Pause you. Where did it go? It was just over here. There's one that had them both on there. We'll watch this one. Okay.
This one needed huge reason.
All right.
I got a big problem over
You need a what?
here.
Okay, we'll get you taken care of in a second, okay? Okay, so this what this is showing is it going to repeat? Oh, it's going to go the other way. I don't need it to go the other way. So what this is showing is that triangle, as that triangle is getting made, let's wait until it gets past. So it's going up and down and around the circle, essentially. And then, oh, my sine values are negative because my sine is my y. So that's why this red line is my y. That's why my sine values are negative. And then if we go click on the I didn't want to do this today. Sine curve in the unit circle. We need the cosine curve. There's the sine one. There's the sine one. Why is it not like... This looks exceedingly boring. Okay, well, he has... How many videos does he have? Way too many. Let's search. Okay, cosine. Here we go. All right. This one. Now that's sine again. Sine. Why does he not have an animation of cosine? Okay. Anywho, now that we've gotten off on this tangent, ironic tangent, let's... Why does no one want to let us visualize the cosine function? No one cares about cosine. Wait, this one's literally called visualizing the cosine function. But it's not visualizing the curve. Here's the one I wanted earlier. Here we go, finally.
There's a lot happening on this.
I think there's something wrong with this video.
Yeah, but I'm basing this off of mine. Wow.
That's all you.
That's cool.
I love Braille. I was saying.
Here we go! Whoa!
Hey, buddy.
Wow, okay, so red is sine, blue is cosine. Red is sine, blue is cosine. Guys, I'm doing this for you. You asked for this. Okay, red is sine, blue is cosine. So there's our sine curve. Same from the last one. It goes up, down, back around.
How does this turn into
Up, down, back around.
Like, how does this turn into that?
Well, this animation's not great. And then cosine starts at 1 and goes down, up, back around. The video we literally just watched.
where does the straight line on cosine, when it gets graphed, how does it turn into a curvy little thingy? So like how? It's a straight line here. What numbers in here
line,
turn it into this?
Right. I don't even think. If I had to guess, I'd say it's because it's not a straight line.
But it's a straight line there.
Okay, this video that I'm trying to. Okay,
Here is a straight line.
so do you see the triangle? The triangle with the dot at the bottom of it.
Yeah.
So this triangle.
Yeah.
As that increases, it is controlling the y-axis, or the y value of this line triangle right here is controlling the sine graph. So see how it's going up? And then right there is our maximum.
Oh, so does
And then it starts, and so then as the triangle continues to move around the circle, it goes down,
Okay, that makes a lot more sense.
and then it's at 0,
Whoa!
Yeah, this makes sense, dude.
and then it's going down.
That's how you need to know how to make more sense.
We should. This makes a lot of sense. So then cosine
And then
is
these
the same
are-
thing.
So,
Yeah, cosine just starts at 1.
are those your periods?
And so then right there, that's one period of the graph, because you've gone around right
And that's the second period.
there. No, that's a whole period, because that's 360 degrees worth.
No, that's what I'm saying.
No, the whole thing is one period. One repeat is one period. Okay, so, hi. If you want to get started on your assignment, you can do the sine and cosine problems. I'll give you your values. Or should I just give you your values for tangent now?
We might as well do tangent.
All right, let's do tangent now, and then I'll give you a work day tomorrow because it's Friday and I really don't want to do anything. All right, so if you let me give you your tangent values now, guys, Jordan, Mason, I'm willing to take your suggestions and try to help you guys more, but you need to help yourself.
Okay.
And if we're wandering around taking my supplies from every table that I have spent time outside of the school day organizing, set them all down right now. You don't need any of them. Okay, so, all right, so let's talk about tangent. Oh, we're not even going to do an example of this. Let's talk about tangent, and then you guys can start working on your assignment tomorrow. So, my graph, y equals tangent of x. I'm actually going to do an entire period of this function. What?
I need an eraser to continue.
Okay, there's some back there on that bookshelf by Azion. Okay, so we are going to actually do an entire period of this function from negative pi over 2 to pi over 2, because that's where one set of our vertical asymptotes are. So negative pi over 2 to positive pi over 2. And we have our tangent function that is at 0, 0. And then it, a quarter of the way through the period, it's at 1 and negative 1. And then it reaches these vertical asymptotes. That should be there. Okay, so our inverse tangent function is going to have to go from negative 1 to 1. So our domain here is negative pi over 2 is less than x is less than pi over 2. The reason why it's less than is because you never reach those vertical asymptotes. Okay, so then our graph of y equals tangent inverse of x. This is my x-axis. This is my y-axis. My y-axis needs to go up to pi over 2 and down to negative pi over 2. And my asymptotes are now going to become horizontal asymptotes.
So the asymptotes are on the periods, right?
For tangent, yes. Because for tangent, the period is pi, whereas for sine and cosine, the period is 2 pi, but we only do 1 pi for inverse functions. Okay, so then I had a point at, I should label this as like 1 and negative 1. I had a point at 0, 0, so I still have a point at 0, 0. And then I had a point at pi over 4, 1. So I should have a point at pi over 4, 1. Sorry, 1 pi over 4. And then I had a point at negative pi over 4, negative 1. So I should have a point at negative 1, negative pi over 4. And then it's going to curve this direction. And since it has those asymptotes and it has no restrictions on my y values here, it's going to have no restrictions on my x values here. So my domain is actually going to be all real numbers for my tangent function. Okay, for tangent, we have way less values for our inverse tangent function because we aren't going to have a value of negative pi over 2 because tangent is undefined there. We're not going to have a value for positive pi over 2 because tangent's undefined there. So we're going to have the same values of sine from negative pi over 2 to pi over 2, just not including negative pi over 2 and pi over 2. So our values are going to be theta and tangent of theta. So we're not going to do negative pi over 2, but we will do negative pi over 3, negative pi over 4, which would be negative 45 degrees, and negative pi over 2, and then 0. And then we repeat these positive pi over 2, pi over 4, pi over 3. Okay, so then our values for tangent of 0 is 0. That's my pink pen. And then tangent of pi over 2 is 1. That should not say pi over 2. That should say pi over 6. Sorry. Everybody erase or cross out. Get white out for me later if you need it. I was like, we specifically can't do pi over 6 or pi over 2. Okay. So tangent of pi over 6 is going to be 1 and negative 1. That's not true either. Why is my brain broken?
Because we had a week off.
I know. Yeah. Okay. Rewind. Tangent of pi over 4 and negative pi over 4 is 1 and negative 1. Negative 1, positive 1. Okay. Then tangent of pi over 6 and negative pi over 6 is square root of 3 over 3 and negative square root of 3 over 3. And then tangent of pi over 3 and negative pi over 3 is square root of 3 and negative square root of 3. Whew. And then tangent of pi over 2 and negative pi over 2 would be undefined, and you can't do that. It's not part of our. Yeah. Okay, so it is 10:19. The bell rings in 3 minutes. I'm going to give you guys tomorrow to work. It's not going to take you the entire class to do the assignment, so you can work on old stuff too. And maybe I'll try to find some more